Hi everyone, I'm Miro from CogniCore AI. Today, I'll be showing you how to use the new HiDream text-to-image model in ComfyUI. And we will also compare all three versions of this model. ComfyUI recently added native support for this model, which makes things way easier. This is a 17 billion parameter model with a mixture of experts in each block, making its architecture pretty complex. It's got the best prompt adherence among all open source text-to-image models and even beats the OpenAI image model on leaderboards. This model comes in three versions: full, dev, and fast. The full model, as the name suggests, is the full non-distilled version and the highest quality one, needing 50 steps. Though I think you can get solid results with 30 steps too. Next, we have the dev version, distilled from the full model, requiring 28 steps. Lastly, we have the fast model, the Speed King, needing only 16 steps. Here, as you can see, we're getting the non-distilled model too. Unlike Flux, where training on the distilled Flux dev caused issues like concept bleeding and trouble using two LoRa's together. I'm hyped to think we can fix those headaches with this HiDream full model. Now, let's jump in and see how to work this in ComfyUI. I'll set up my pod first. Here, I'll use an RTX A6000 GPU because we'll need 48 GB VRAM for the FP16 and BF16 model weights. I will set my storage to 110 GB since we're downloading all three models for comparison, and each is about 35 GB. Once that's done, I'll expose port 3001 and deploy my pod. Once the pod is ready, I'll connect to it. Now, I'll install ComfyUI quickly. If you want to install ComfyUI on RunPod super quick with automatic installers, check out the video in the I button where I've shared our automatic installer script that sets up ComfyUI in one click. Okay, so now I have ComfyUI up and running. Now, I'll install the full model in the text encoders and the VAE. This model has 4 text encoders. I'll upload this download script to grab them super fast. You can find this file in the description for free. Once the file is uploaded, open a new terminal. Paste this command from the description and press enter. It'll start downloading all the required models. As you can see, it's pulled the LMA 3.18b Instruct FP16 model. This isn't the FP8 version from ComfyUI's Hugging Face repo. It's the original I merged myself. Then it's got the VA Clip G, Clip L, HiDream full model, and the T5 XXL FP16. This isn't the FP8 from ComfyUI's repo either. They reduced it for VRAM, but we're good with 48 GB VRAM on RunPod. Now, as you can see here, the models are downloaded in the ComfyUI models folder. So we'll move them to their respective folders. Put the VAE file in the VAE folder, Clip L and Clip G in the text encoders folder, HiDream full in the diffusion models folder, and then the LMA and T5 in the text encoders folder too. Now we need to download the remaining 2 models, the HiDream Dev and HiDream Fast models. For this, we use our Hugging Face Superfast Model Download Upload notebook. So upload this notebook to your workspace. Once uploaded, open it and start setting it up as we did in our previous video. If you want to download models from Hugging Face and upload your models or train LoRa's to Hugging Face, watch my video on the I button. Get the notebook file and learn how to use it from that video. Now it's downloading the HiDream Dev model. You can ignore this error. It won't show progress for such large files, but it's working in the background. Once downloaded, you'll see a confirmation like this. Your download speeds also depend on your pod's internet speed, so make sure you choose a good pod. After this, we'll download the HiDream Fast model. So, this model is also downloaded. We have all our models downloaded and placed in their correct folders. I'll now open the ComfyUI using port 3001. Now let's grab the workflow from ComfyUI's example workflows blog here. I'll take this image and drag it into our ComfyUI, and it loads the workflow for us. Here, I'll change the Save Image node to a Preview Image node so that I can save whatever image I want myself, and it doesn't save every image it generates. I'll also rename this node as Full because we'll be comparing all three models, and it'll make it easier to find which image was generated by which model. I'll also install some custom nodes that I like. Now I'll adjust the settings according to the recommended values. First, I'll change the steps to 50, then change the sampler to UniPC and fix the seed so that our tests are more stable. I'll set the models in the nodes correctly. First, we'll be testing the full model. I'll keep the resolution at 1024 by 1024. Add our first prompt and click Run. And to monitor our VRAM consumption, I'll install nvitop using this command. Pip install nvitop and press Enter. Once finished, type nvitop to run it. Now it shows us the VRAM consumption and other GPU stats in real time. You can see it starts loading the model. First, the RAM spikes up, and keep in mind we need more than 50 gigabytes of RAM to run this model, so make sure your pod has enough RAM. I have 62 gigabytes in this pod. And now it starts loading the model into the VRAM, and it peaks at 45 gigabytes of VRAM. Now our image is generated, and it's a pretty good image. Now let's test the dev model with the same prompt and same seed. I'll disconnect this preview image node from here and add a new one and name it dev and connect it. I'll now change the model to dev, steps to 30, and then shift to 6 and CFG to 1. I'm keeping the sampler and scheduler the same to stabilize the testing. And click on Run, and it starts generating the image. The image is now generated. Now let's test the fast model. For this, I'll do the same. Disconnect this node, add a new one and rename it to fast, change the model to fast, shift to 3, steps to 16, and keep the rest of the things the same as for the dev version. And click on Run, and it starts generating the image. The image is now generated. I'll now test a few more prompts like this for all these models. And in the end, we will analyze all the images together. Okay, so now we have generated a few images with different prompts that test how capable these models are. So let's analyze them one by one. All three models skillfully produced high-quality, close-up portraits capturing the requested golden hour outdoor setting, featuring a beautiful woman with wavy auburn hair, gentle backlighting, and realistic skin detail against a blurred autumn background. Each successfully rendered the sun-kissed look and subtle makeup. Significant divergence occurred in specific features. The full model adhered most closely to the prompt's explicit details, showcasing prominent and numerous visible freckles and distinctly amber eyes as requested. Conversely, the dev and fast models, yielding virtually identical images, presented much subtler freckles and depicted eyes with a more hazel greenish hue, deviating from the specific amber request. Therefore, while all variants generated excellent portraits overall, the full model demonstrated superior fidelity to the explicit details regarding freckles and eye color mentioned in the prompt. All three models successfully rendered high-quality, realistic portraits matching the core request. A beautiful woman with casually pulled back curly dark hair facing a window, with soft daylight illuminating half her face and highlighting her features. They all captured the peaceful, intimate atmosphere, gentle expression, and details like skin sheen and lip texture effectively. Minor details like visible eye veins were not distinctly apparent in any version. The main point of divergence is that the dev and fast models produce virtually identical images, featuring a multi-pane window and a clearer view of books in the blurred background, fully aligning with the background description. The full model presented a slightly different composition, with a simpler window frame and a less defined background, though it still strongly adhered to the overall prompt regarding lighting and subject. In essence, all performed exceptionally well with high consistency, particularly between the nearly indistinguishable dev and fast outputs. All three models successfully generated high-quality, cinematic close-ups resembling a fashion editorial, adhering to requests for natural skin sheen, pore detail, an intense gaze, and a high-end look. Each included the Vogue Spring Revival text overlay. Key differences emerged in interpreting specific stylistic elements. The full model best captured the dramatic lighting, with strong shadows and the wind-blown hair partially covering one eye, creating the most dynamic effect. However, its background leaned warmer than the requested cool-tone pastel. Conversely, the dev and fast models, which produced nearly identical results, excelled at creating the soft pastel background with cool-tone styling, but featured less dramatic lighting and hair movement, with the hair not significantly covering the eye. Therefore, while all variants produced excellent portraits, both prioritized drama and hair dynamics, while dev and fast better matched the requested background and overall color tone. All three models successfully generated visually stunning landscapes capturing the core request of a rocky coastline at sunrise with great detailed textures, crashing waves, swaying grasses, and birds in V formation. The image quality and realism, particularly in water foam and rock detail, are excellent across all versions. However, a critical difference in prompt adherence emerges. Only the full model correctly included the requested distant lighthouse, faintly glowing. Both the dev and fast models, which are nearly identical to each other in composition and sky rendering, completely omitted the lighthouse. Additionally, the full model arguably depicts the cool morning mist more effectively than the other two. Therefore, while all variants produce high-quality results, the full model demonstrated superior adherence to the specific elements detailed in the prompt, particularly the inclusion of the lighthouse. All three models demonstrated excellent performance in interpreting the core elements of this prompt, successfully generating images resembling traditional oil paintings of a snow-covered alpine landscape at dusk, including mountains, forests, a reflecting lake, and a cabin. However, a key difference lies in the rendering of the painting style itself. The full model most successfully captured the requested thick brushstrokes showing snowy texture and impasto painting style, presenting a visibly textured surface with more pronounced brushwork, especially in the sky and snow. In contrast, the dev and fast models produce very similar, smoother results with less apparent texture, diminishing the requested impasto effect. Additionally, the full model features a more dramatically vibrant sky color palette compared to the softer, more traditional dusk hues seen in dev and fast. Therefore, while all captured the scene, the full model adhered more closely to the specific textural and stylistic instructions of the prompt. All three models successfully generated dynamic anime-styled scenes featuring a pink-haired girl in a school uniform within a graffiti-covered city alley at sunset, capturing the core aesthetic and setting requested. They all depicted a mid-air kick, although none perfectly conveyed a distinct spinning motion. It included elements like fluid hair and expressive faces. The full model presented a slightly more grounded sidekick pose, but had the most prominent glowing trims on the uniform and a stronger neon rim light effect. The dev and fast models rendered very similar high kick poses, with fast notably including the requested sweat beads, which were absent in the others. However, specific details like clearly flexed toes, action lines, and sharp window reflections were largely omitted across all three versions, and the futuristic aspect of the uniform was subtle. While generally successful in capturing the style, the model showed variability in interpreting the precise action and incorporating finer details. Full model arguably comes closest to being the winner overall. All three models successfully generated a surreal, moody close-up portrait reflecting the core request, featuring a woman's face against a dark background with purple and blue ethereal lighting, high realism skin, and reflective eyes. Each included floating text and glowing symbols. However, significant variations emerged. The full model adopted a profile, three-quarter view, and stacked the misspelled text dissolve vertically with distinct star-like symbols, also best capturing the underwater hair effect. The dev model presented a frontal view, placed the same misspelled text dissolve over the subject's eyes, and used similar star symbols but with less hair movement. The fast model, also frontal, significantly altered the text formatting to all caps. Dots, like light, placed separately above and below the face, used different geometric symbols, and notably cut off most of the text. Therefore, while the fundamental concept was grasped by all, the specific interpretation of text arrangement, spelling accuracy, symbol style, composition, and subtle effects varied markedly across the variants, with all misspelling dissolve. But overall, full was a clear winner. All three models successfully executed the complex split-scene concept, depicting a woman's face seamlessly merged between a neon cyberpunk city environment on the left and a serene golden hour forest on the right. They accurately rendered the distinct lighting for each half and included the requested floating leaves in the forest portion with high overall quality and consistent facial rendering. Variations appeared in handling the glowing UI text overlays. The full model correctly placed System Live as a plausible floating UI element within the lower left of the city scene, consistent with the prompt. The dev and fast models, conversely, interpreted this as an overlay directly across the subject's eyes, styled slightly differently in each. Additionally, none of the models significantly differentiated the hair flow between the two halves as subtly requested. While the core creative request was met effectively by all, the full model demonstrated a more contextually accurate interpretation of the UI text placement compared to the other variants. All three models demonstrated exceptional performance in response to this atmospheric prompt, successfully capturing the requested scene of a woman sitting sorrowfully near a rain-streaked wooden-framed window during a nighttime thunderstorm. Each image effectively conveys the heavy, cinematic mood, featuring pouring rain, visible water droplets, external lightning flashes, faint blue facial illumination, glistening tears, and wet, clinging hair strands as described. The full model depicts the woman in profile, while dev and fast present a more frontal view, but all capture the required sorrowful expression and overall prompt elements with high fidelity and quality. In this instance, there are minimal discernible differences in adherence or image quality between the full, dev, and fast versions, suggesting all variants handled this emotionally charged descriptive scene with remarkable consistency and success. All three models successfully interpreted the core concept, depicting a woman mid-turn before a wall covered in Polaroids of herself, bathed in soft light, capturing the requested emotionally rich and somewhat surreal multiverse feel. The main subject is rendered with high quality and anatomical correctness across full, dev, and fast. However, significant differences emerge in handling the detailed background elements. The full model performed best at incorporating the specified Polaroid captions, rendering somewhat legible text like Paris 2023 and NYC 2021, albeit with some inconsistencies. The dev model showed a noticeable decline in text quality, with captions becoming largely garbled, and the background photos appearing slightly less detailed. The fast model exhibited the poorest performance on text rendering, displaying mostly nonsensical characters on the Polaroids, and the background details were similarly less sharp than the full version. None of the models clearly executed the slight glitch effect along photo edges. In summary, while the overall scene and main subject were consistent, adherence to specific details like text rendering degraded noticeably from full to dev and fast. This prompt, requesting a sexy Instagram model posing on a high-rise balcony during golden hour, yielded highly successful and remarkably consistent results across all three models. Each model accurately captured the specified subject: confident pose, one hand on railing, other tousling hair, tight mini dress, golden hour lighting with warm highlights and contouring shadows, blurred city skyline background, and sultry gaze. The image quality is excellent in all versions, with realistic skin textures and anatomically correct rendering. The primary difference lies in the dress color, with the full model generating a darker dress while Dev and Fast produced a lighter, tan version. Overall, this test demonstrates strong performance and consistency from all model variants when handling portrait-style prompts focused on ambiance, specific lighting conditions, and clear subject description, with minimal trade-offs apparent between full, Dev, and Fast. Despite a prompt requesting a specific twisted triangle yoga pose, all three models failed to accurately generate the required action and exhibited significant flaws. The full model, while rendering some elements well, produced a glaring anatomical error, depicting an extra leg merged near the woman's hand. The Dev model not only generated an entirely incorrect pose, but also suffered from a severe anatomical issue, appearing to omit the woman's back leg entirely. Similarly, the Fast model failed to capture the correct twisted triangle pose, even if it avoided the more extreme anatomical distortions of the other two. Ultimately, this test demonstrates a critical weakness across all variants in interpreting complex human poses and maintaining anatomical coherence, rendering the images unsuccessful despite the instructions provided. In this test requesting a fit man doing explosive jump squats, captured at peak jump in a high-energy gym, all three models produced visually high-quality, coherent images regarding the overall scene, excelling at rendering the gritty cinematic atmosphere, lighting, muscle definition, and gym setting. However, all three fundamentally failed to depict the core action accurately, rendering a static deep squat instead of the requested peak jump, and incorrectly showing trainers instead of the requested bare feet. Furthermore, significant anatomical errors plagued the hands. The full and Dev models both clearly depict extra fingers, while the Fast model appears to show fewer than 5 fingers. These finger count errors, combined with the failure to execute the dynamic action, highlight persistent difficulties these models face with accurately interpreting physical actions and rendering correct anatomical details like hands, even when the broader image composition and quality are high across all variants. So here is my final verdict. There is a clear weakness across all variants that lies in interpreting complex actions like specific exercises or yoga poses. Use Fast for consistent, good quality results. Full offers the potential for greater detail and nuance, capturing subtle prompt elements more often. Dev sits as a potential middle ground, perhaps aiming for quality closer to full with potentially better speed, though in these tests, it often produced results visually similar to Fast. While all models show promise, significant improvement is needed for complex physical depictions. Thankfully, these seem like addressable training challenges, and the potential for community-driven fine-tunes and Loris offers exciting possibilities for refining this model further. So this is all for this video. Hope you found this video helpful. If you did, please like this video and subscribe to my channel to get more amazing time-saving and easy-to-follow videos. This is Miro, and I'll see you in the next one.